Hi guys, welcome to our first video on AP Physics C. We're going to go over our first section, which is kinematics, which is basically the study of motion, where we're going to be interested in position, velocity, and acceleration. So if you remember from calculus, you studied maybe some real world examples of position, velocity, and time. You learned that the derivative of the position time graph yields the velocity time graph. And then if you take the second derivative or just the first derivative of the velocity time graph, you'll get the acceleration time graph. Okay, so if you see here, I have a parabolic curve, and then I get my straight linear function, and then I just get a constant function down here. So you're just taking the derivative. You've already all done this before, and then you can get each function. In this class, we're going to want to go back and forth. What if I give you the acceleration curve? How can you get the velocity curve? Okay, if you have the velocity curve, how can you get the position curve? Okay, so again, we need to be able to go back and forth. And so that means we're going to need to learn how to integrate. Okay, so if you've taken calculus, this is not new for you. But for those of you who only took pre-calculus and are currently enrolled in calculus, you're going to learn this soon, but I need to teach you a quick and easy way to integrate. And don't tell your calculus teachers because they're going to give you the hard way first, okay? They're going to actually start out by telling you that we want to find the area under the curve. Okay, that's what an integral does. Just like the derivative helps you find the slope of the function of the tangent line of the function at a specific point. When you integrate, you get the area under the curve from some point A to another point B. Okay, because if you have a curve, you could have an infinite area if you're going, the entire area. We don't want to do that. We need to set bounds. So we just want the area under this curve here, and we say we want it from some point A to some other point B. Okay, this little squiggly line right here, it just means to integrate. Okay, and it's going to tell you they want the integral, they want the bounds to be from A to B. So this point A here to that point B there. Okay, so just like when you're taking the derivative and you want to know the slope of the derivative at a specific point, you have that specific value where you can find the slope. Okay, so let me go back. All right, so again, this squiggly line means to integrate. And integration is basically just the opposite of differentiation. When you integrate, you find the antiderivative. Okay, so the antiderivative is the function that reverses what the derivative did. Okay, so one function can have a whole bunch of antiderivatives, okay, but they all take on the form of a function plus some constant. And if this is not making any sense to you, and if this looks scary over here, don't worry, I'm going to go over some examples soon, okay, but I just want to highlight what we're going to do right now. All right, over here on the left, these are some integration shortcuts, okay, and you're going to have access to these equations on the AP Physics C exam. Okay, but you probably will have them memorized by the time you take the exam because they're the most basic functions or integration functions that you're going to learn. You're going to learn a lot more complicated functions to integrate in your math class. Okay, in physics, we don't focus on making the integration very, 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 very complex, but just that you know that, hey, I'm supposed to take the integral, I need to integrate, and that's how I'm going to get the answer. Okay, so just to recap, we're going to need to be able to go back and forth between the position, velocity, and acceleration curves. Okay, so if we can't take the derivative, we have to take the antiderivative to go backward. Here are some formulas, and then again, the integral is just the area under the curve. All right, so join me in my next video. I'm going to show you guys some examples next. All right.